Hello, Mario! Calculating joins, vectors, missing lines, inverses, or whatever you wish to call them, from total coordinates. In this video we're going to be looking at how to calculate the join, or the inverse, between 2 points A and B. I've got their coordinates here written at the top of the page. 7327.460 north, 3564.276 east for A, and 6589.406 north for B, and 3002.402 east. Now these coordinates are just assumed coordinates. They're not on any projection. They're on a plane projection. There's no scale factor included in them. These are important facts to know because it's very important that you know where you're getting your coordinates from. Some coordinates are adjusted for projection, some for sea level, so it's most important that when you're calculating between coordinates that you know the source of your coordinates and what type of coordinates you have. So these are just straight off plane coordinates, so they're on a flat earth. First thing to do is probably to draw a diagram, which I've done here for you, just showing the relative position of both of them, and then you can, by dropping in the various lines, put in the component parts. And you can see there in the magenta how I've calculated the component parts there. They form a right angle triangle, so it's quite simple now to calculate the distance using our old friend Pythagoras. So here we have 738.054, so we can do that quite easily on the calculator. 738.054, and we just square that, enter, and 561.874 and we just square that and add that to what we previously had, take the square root of that, and there we get 927.5916, which I've rounded to 927.592. I've done these calculations here from working these out just straight from the coordinates. Obviously the northing of A there, subtract from that the northing of B, that's where we get our 738.054. I've shown it as negative because we're calculating from A to B, hence the arrow there on the resultant vector there, and we can see that we're going from A down here, which is negative 738.054. Using the easting of A, subtracting the easting of B, because that's the easiest calculation to do, we get 561.874, and I've shown that as negative because that's the direction that we're travelling. So the next thing to do, I've just put those directions in there because we're going to use those a little bit later on. So the next thing to do is to calculate the bearing. We've got the distance, and we can see that the bearing comes from north all the way round to there, but we can see that 180 degrees of that, we can work that out ourselves. If we just work out angle beta here, we can work that out and add 180, and that will give us the bearing from A to B. So the bearing from A to B, of course, we use the tangent opposite over the adjacent. So here it is here, tan B equals the opposite, which is 561.874 over 738.054. I'm just going to put a little decimal point in there at this point in time because I can, and it's annoying me that there's one missing. Oops. We'll just there eventually. There we go. So and we can put those into the calculator now, so let's just go, just clear everything. 561.974 check. That's 874. Enter. 738.054. Divide, and then tan to the negative 1 of that, tan to the negative 1, which is there, and that gives us 37.2817, which of course we know is in degrees and decimals, so we convert that to hours, minutes and seconds, which is 37:16:54, and we just add 180 to that to give us our bearing, 217:16:54. Of course, as I've shown you earlier, there is an easier way of doing this once we've got our two ordinates there, and that is to use the polar rectangular conversion. And to do that there, what we would have to do is go 561.874, change the sign of that, enter, 738.054, change the sign of that, and then use the polar to rectangular, so that would go, in this case, a rectangular to polar to polar. There's our distance, 927,592, xy on that. It's negative, so we add 360 plus, and then we convert that to hours, minutes, seconds, 217 degrees, 16 minutes and 54 seconds. And if we really wanted to just check it out to make sure we've got things fairly right, we could just do the reverse, 217.1654 to hours, enter, 927.592 to rectangular, and there we get our 738.054 north and 561.874 east. But wait, there's more. There is actually an even easier way than that, using some of the features of this amazing little calculator here. So let's have a look at those. Let's see if we can make it even easier. And here we are. I've got a little calculator routine for you. So first step is draw a diagram. I've left the data on there, just as a reference, and once again I've still forgotten to put my decimal point in here, which I'll just do now. There we go, another couple of clicks. Okay, now this way is even easier again. So the first thing is to go F sigma, so that clears all the storage memory and the statistics memories, and then we input the coordinates of A and we put them in easting first. So 3564.276, enter, and then we put in the northing, 7.46. We don't need to put the 0 in. And then what we do is we go sigma minus, which is G sigma minus. And that gives us this -1 up here, which tells us that we've used the sigma minus once. Now the next thing we do is we put in our point B, easting first. So 3002.402, enter, and 6589.4 6, and then we push the sigma plus button, sigma plus, like so, and then recall sigma plus, and there you see we've got the 738050 and the 561874. So that was quite a lot easier. And then of course we go, we want that to be that's in rectangular to polar. There's our distance 927592, xy that, add 360 because it's a negative, 360 plus, and then convert that to hours, minutes and seconds, 2171654. So that's quite a lot easier using that little calculator like that, and that's how we can work out the inverse between 2 points. I must stress that these are plane distances only. These are not projection distances, and so you must be very careful that these are based on flat Earth, not a geodetic survey, and you must be most careful of that if you want to go that extra distance and work out geodetic values. You would have to use geodetic software to do that, but over short distances these are more than ample. So there you go. You now have something to work with in terms of finding the bearing and distance between 2 points when you know their total coordinates.